is Jalaluddin. My name is Jalaluddin, and you can call me Jalal for short. So today, I'll be talking about something which is known as feature engineering, looking at the databases. So the idea of my presentation is to talk about first, what are the different databases we can look into, right? We have to get the data. That's the first step. Next thing, once you have the data, we do something which is known as feature engineering. Okay, I'm not talking about data cleaning. Data cleaning is something else. Okay, data cleaning is about you have some missing values or you have some outliers. So feature engineering is different from data cleaning. Okay. And then, just to summarize my entire presentation, I'll be talking about an unknown problem. I will give an opportunity to the listener to share your own ideas, and then I will give my own solution, and then we'll have some question and answer session. And towards the end, I'll be talking about how you can get your first Canadian job. I believe, because I'm a graduate of this B412 program at George Brown College, and coming here as an immigrant, looking for the first job. I know most of my other classmates, they were also immigrants or international students. So I will share my own experience. And if you have any question, I'm happy to take questions regarding searching for the job in Canada as well. Okay, guys, so databases, market research. So there's a variety of different databases which you can look into. And the links for all these databases you can find from the George Brown College Library databases. But in particular, there are some databases which are way more important for us being a data scientist or a data analyst, making decision for the business processes. In particular, VV data is one of the most important one. We have IBIS Word, and then we have the Euromonitor and so onwards. So I'm going to talk about, first of all, about the VV data. VV data. And before I jump into VV data, I must clarify. So things like the market research and the database data set, they are different. So when we are talking about the data set for the data set databases, we are talking in the direction of machine learning. So you're given a data set, and on that data set, you can then apply your machine learning problems. So, all those classification or linear regression problems and so on. So, okay. So these are two different families of databases where you can look for the data. One is going to help you to generate the data you want. The other one is just going to give you the data set in the more raw format. Okay. And these are just some of the representative data set. And of course, there could be many other sources for these data set as well. Okay. So, when we talk about business market research, what do we mean here? So my objective is that I want to start a new business. Okay, so if I want to start a new business, I need to understand the market. I need to understand my customers. So it starts with a certain business problem I have. I could be having my own hypothesis. I could be thinking that my potential customers could be so-and-so. And because they are so-and-so, I need to design my products or the items which I'm selling should be meeting the demands of the customers. So the important thing is to understand the market, and then you also have to understand the customer as well. But there is a very important thing: getting the right data and the right interpretation is very important. So there are two things here: right data, I will be talking about this, and the right interpretation. And these two are like two different concepts. Just imagine you go to a bank. What is the information they ask you about? Do they care, what is your favorite cuisine? Or do they care, what is the favorite movies which you like to enjoy? Or do they care, what is your net worth? And anyone from the audience, I have two audience member.
Definitely, they obviously care about our net worth the most.
Yeah, exactly. Okay, you got the right answer. Okay. Okay. Of course, because when you're going to the bank, they want to know about your net worth. Someone who has a higher net worth could be a potential customer to whom they can market their mortgage, their insurance, and other banking product. Things like favorite cuisine, yeah, it's a useful information. It's helping you to understand the customer, but really it's not. It does not suit the needs of the bank. Okay, Let's go to the next slide. Okay, what you see here, you see the amount of money which US government is spending on science, space, and technology. And then you also see suicides by hanging and by suffocation. Can we see a correlation? And I think anyone can see the point here that a correlation exists. So how can we reduce the suicide by hanging? Does it mean that the government has to reduce the spending on science, space, and technology? Any opinions?
No, I mean they can be correlated, but it doesn't really establish the relationship that
Yeah,
specifically US spending is having that kind of effect
exactly.
on suicides.
Exactly, you
It can
got it right.
also be because there can be other variables
Exactly.
considered.
Yeah. So exactly the idea is as follow. You got it right. So this is the point I've made at the bottom of the slide. Correlation does not imply causation. So just because you have correlation between two variables, it does not mean that one variable is impacting another variable. Okay. And then we have another example here. The number of people who drawn by falling into a pool correlates with the number of films in which an actor appears in. Okay. And they correlate, but just because Nicolas Cage stops appearing in movies does not mean people will stop dying from this event and so on. So the idea is that, we could be having the data could be telling us a story. But the thing is, even though it is telling us a story, do we have we got the right variables or not? Or probably we are making a misjudgment about the data. Let's move forward. So having that understanding, now I will talk about the databases. Okay, so VV data. So what we do in the VV data, I will open up my browser. I hope you can all see my browser. Yes.
Yes, we can.
Yes. Yeah. Okay. Great. I will just log in again. I just got disconnected because of a period of inactivity. Just give me a second. Okay, guys. So the way we try to fetch information from VV data database, is just imagine this as some sort of database in which you can tell the database what is the information you want. So let's say I have some questions here. So let's say find the number of people who drink coffee in the last 6 months, who are female and who live in Ontario. Okay, so if this question was given to you in your database class, you would write an SQL pseudocode which looks something like this, and this is also a possible interview question. So if you go to an interview for a data science position, they will ask you, okay, this is a business problem or a user story. Can you write a SQL query for this or not? Okay, so this is what it will look like, but we will be, implementing the same thing on VV data. So the first thing, we want to find the number of people who drank coffee within the last 6 months. So let's go for here. Coffee, it will come under beverages. Let me search for, no, I'm in the wrong section. Yep, no, I got it. Okay, so we will click on that particular portion and add this as a question, right? So now what is the other information we need? We need to add some filters. So we need only those people who are female and who live in Ontario. So I will remove my search query and I will look for the demographic, and I think I need something which has gender in it, and I will click on my search. Yep, I got it. So add this as a filter. So what the filter is going to do, the filter will, after I have applied the filter, in the table, I will see the result of those people who are female. So once I have got the filter here, I can right click on this and I will select the answers, right? So I'm looking only for the users or the customers who are female. I click on this and then I'm good to go. Then the additional thing which I need is people who live in Ontario. So again, something like a province. And then once I have typed in province, I will click on the search button. demographic, I think I'll be able to, yeah, geography province, add this as a filter again. And then, and you know, when you're adding this as a filter, so let's say I remove this as a filter. Before you add this, you can see the list of options you have. So when you click on view answer, you can see the names of all the provinces here. Okay, so let me close this. Okay, add as a filter. And then I'm only looking for people who live in Ontario. I got my filters now. Now the next thing is, what is the information I'm looking for? So it could be anything. So let's talk about some mutual funds. Okay, so people, female, who drink coffee and who have some mutual fund. Okay, so I will be adding this as a split. Right, so now I can generate my table. So you can see, so you can see now that I have got the results, and now based on these results, I can now start making some of my interpretation about the data. Okay, again, at this point of time, I only have this correlation. I'm not establishing any causation here. Okay, so I just like did everything in advance just to, of course, I've shown, you know, how you can get a table like this, how you can use the question and the splitting and the filter. So guys, now we have something in front of us. Let's look at the data. Can we see any relationship between people who drink coffee and people who have mutual funds? And, you know, gender is female and Ontario, okay? So just straight away looking at the table, I think our judgment will be there is no sort of correlation, because, you know, these two numbers, 76 and 72.5, these numbers are quite close to each other. Okay, so we can just like reject our hypothesis. Okay, first time mom. Okay, so again, I have female who are drinking coffee, but on my right hand side split, I have got household with the presence of children less than 18 years old. So now we can see some interesting pattern has now started emerging in our data. When you have one kid at home, mom drink more coffee, but when mom have 2 or 3 kids at home, they drink less coffee. Okay, and you know, we can think about a possible reason behind this. So I've written a reason at the bottom. So when you have one kid, you know, they need the entire attention of mom and dad, you know, so you have to drink more coffee. But when you have 2 kids or more, you know, they can play amongst each other. So just to give you an idea that, you know, there are some hypotheses, you know, which we can possibly accept and investigate further. So again, your family doctor would not be telling you about this. So thank your family data scientist. So this information is not, so what I had shown you in the previous slide, this is not the only information which the data scientist can fetch for you. So look at this diagram here. So a person has got some symptoms, and these symptoms can be, you know, having these symptoms could mean that you have a chicken pox or you have a smallpox. How can the doctor diagnose whether you have the chicken pox or you have the smallpox? So let's look at this side. So delta C means chickenpox and delta S means smallpox. Having these symptoms means you are more likely with a probability of 0.9 to have smallpox. And you have a smaller probability of having the chickenpox. But you know, when we take into consideration the Bayesian equation, so I hope you have studied this in statistics. Looking at the results at the bottom of the slide, the probability that you have chickenpox is more than 98%. And the probability that you have smallpox is less than, is almost equal to 1%. Even though the likelihood of having smallpox was greater than the chickenpox. So data science is not just limited, you know, so I can tell you that nowadays data scientists are able to outsmart doctors. There are now research papers which have shown, you know, by having the sufficient data, and you know, when you input the values or the symptoms or the conditions about the patient, the machine learning algorithm can give you better performance compared to the actual doctors whom you visit in your medical center or the clinic. Okay, but before we jump into any conclusion, wait, what is the limitation of my results? So going back to my previous slide. So In my previous slide, I made a conclusion. Yes, people who have like one kid, they drink more coffee, but I have a limitation in my data. That data was primarily, primarily came from those people whose first language was English. Can this data be applied to someone who's not speaking English? It could be the Greek language or it could be some African language. So our data has some limitations and we need to look at how good or bad the sampling was. Okay, so Census Canada is a very good source for you to find a demographic profile of your customers. Do you have an aging population or does it have a young population? How multicultural or how multi-ethnic the city is. And if for large metro cities like Toronto, it has its own data. So even its police has its own data as well. So Wellbeing Toronto is one of the platform where we can look about more information about the city in Toronto itself. Okay. So I will illustrate this online. So let me go to Wellbeing Toronto. In Toronto, yes, I've got it. Okay, so again, guys, we can apply these same principles. We can add our indicators. So it could be anything. So I could be interested to know about which localities I can find young customers. Okay, all right. So open this up. I want to find population where the age of the customers is in the range of 20 to 24 or 2024 plus all the way until 29. So I'm combining all these indicators. I want to operate my business in a locality where the customers, their income is high. So I can keep on adding more variables here. Okay, so I do not want someone who's unemployed. Average family in household income, I want to take that into consideration. So so based on whatever variable I want to take into consideration, it will generate a heat map, and based on that heat map, I can then decide in which locality I should be opening up my business. So now you can see I have a combined indicators, and this particular region, it is more dark. And then there are some regions which are not as dark. So this means in this locality, I have more chances of having customers who could buy my product. Okay, so until this point, we know, so I have like given you an overview about understanding the market, about understanding your customers. Next question, how can you identify who are going to be your potential customers? Okay, so have you guys studied something about the Prism customers analysis?
Yes, in our business metrics class, yes.
Sorry, say again?
Business metrics, yes, we have studied that.
Okay, great. So you have an idea about the Prism marketing, the profile of customers they collect based on some postal code. So my question to you now is that, you know who your customers are. Okay, now I want to market my product to new customers. Okay, so now I'm talking about marketing. I have some existing base of customers. So how can I identify my new customers? What would be the approach you will be taking? Any answer from anyone in the audience? We have only 2 members.
I don't know. I think we will segment the customers.
Exactly.
Yeah, and and decide on the basis of similarities.
Exactly. Yeah. Right. Yeah, you got it right. Okay. So again, this is the idea. We perform something which is known as clustering. When we're using the more machine language terminologies.
Yeah, clustering.
Your existing customers. Your existing customers have a profile. They have a profile about age, income, number of kids, and so onwards. Let's try to find a new segments of customers, even though they might not be having the same profile, but their profile is very close or very similar to the profile of your existing customers. Okay, so very good answer. We apply the customer segmentation, or the we just look for the closely related customers. Okay, and then we have seasonal data. So if you want to look at the seasonal data, you have something known as the Google trend. I will just try to go quickly over this. So let's say I had a keyword in my mind before, Niagara Fall, one of the famous tourist attraction in America. So you can see if you want to search the seasonal data, now we can see during the summer, more people were searching for Niagara Fall, as opposed to the number of people who were searching about it during the winter time. I can further look at the information from which region most of my potential customers, so if I have a business in Niagara Fall, were looking the information for. And if I want to take it a step further, I can make the data worldwide. So I want to market my product internationally, right? So apart from Canada, now I can see from Paraguay, Honduras, and Panama, most of my potential customers were searching for information about the Niagara Fall. So again, so if you're a YouTuber, like you are releasing a video about Niagara Fall, you can use this to time the release of your video. And in this way, you can increase the number of the number of people who are viewing your video. Okay, industry report IBES word. So I will just jump over this just because of time limitation. And I wanted to talk something about the Euromonitor, but I checked their website today in the afternoon. They were could not load dashboard error message. But if you want to look at the information, go to the consumer link first of all, then lifestyle, and click on the Explore Now button. Okay, so they have a lot of options and a lot of buttons to click on. Okay, so until this point, I've talked about the database. How can you get the data? Now let's talk about feature engineering. So as I said, I'm not going to talk about data cleaning, about missing or outlier values, about normalization or transforming the categorical data and sanitization and so onwards. Okay, so my main task is feature engineering, the columns. Okay, when we're talking about structured data. Okay, and I'm not talking about the data. Okay, when we talk about data, I mean the number of rows in the table. So how can I minimize or how can I add meaningful columns in my data? Okay, so is more data better or is better data better?
Better data better.
Yeah, better data is better, and of course, more data is also better depending which type of variables we have. So both the answers would have been right. So what is the problem when we have too many features? So too many features can lead to overfitting of the data. Okay, so features, some people use the word of dimension. I'm more comfortable using the word of features here. So this is what the graph looks like. So if you increase the features or dimensions until a certain point, your performance of your algorithm or your predictive analysis will improve. But after a certain threshold, your performance will then start to decrease. So, we have to be careful with our terminology. We are not saying increasing the features will reduce the performance. We are saying increasing it like too much will then adversely affect the performance. So the first bullet point I have written on this slide is about the domain knowledge. Guys, this is really the single most important thing I can think about, being someone who has research experience in machine learning algorithms. If you really want to know which features to work on, you need to have the domain knowledge. To get the domain knowledge, you need to talk to the industry expert, people who are working in that particular field. For example, you're working on some medical problem. You need to talk to a variety of different medical doctors, get their opinion, talk to community health worker. And then based on their feedback, you then have some hypothesis, well-informed hypothesis, and then you can then evaluate your hypothesis. And, if you ever get this question in the interview, how did you train your model? This is one of the best answer, guys. Start your answer with this approach, okay? Because this is one size fit all type of answer. Okay, so, when we are looking at feature engineering, I believe everyone has seen the diagram on the right-hand side of my slide. We have this overfitting and the underfitting problem. So normally we just try a different number of features, or if we were working with neural networks, we try the different layers of neural networks until we get something which is optimal. But the problem with this approach is that this is computationally prohibitive. So even though with this approach, you will get a solution which is optimal. Okay, and this is very important. If you really need something which is optimal, just think about investing some computing resources using an exhaustive search algorithm. So exhaustive search algorithm means you try each and every single possibility, each and every single combination. Okay, but that's going to take a whole lot of time. It's not practical for most of the situation. So if most of the real data, raw data set, they have like hundreds of different variables. So when you talk about 10 features, so it means choose one features from 10. So when we talk about one features, we have like 10 different possibilities. When you talk about two features from 10, you have to apply the combination formula, and then, these numbers then have to add up together. So the number of possibilities, they increase factorially. Okay, so the main message is that this approach is not practically possible, but yes, if you are working on something which is critical data, medical, some sort of military kind of thing, yeah, it makes sense to invest your resources on computational resources. Yeah. Okay, so we do have some suboptimal heuristical approach. So you would have heard about forward selection and backward selection. They try some approach. Okay, you start with a lot of variables and one by one you remove them. But but one thing which is not clear: how do you decide which one to remove, or how do you decide which one to add? Okay, so this is just like a heuristic. You try something based on your gut feeling or whatever the Python Anaconda is doing it for you. You don't really have much control over the data here. Am I on the right page? Yeah. Sorry, 1 second. Yeah. Okay, so there are some good approaches. So for example, if I have got categorical data, so now I have got categorical data about the heat of the product. So hot means the product is too much in demand. Warm means it is in demand, but it's not too high. Cold means the product is not like much in demand. But you can see from my sample, the number of products which are hot is just like 2 or 3 products. So what can I do here? I can combine the hot with the warm here, right? Because the thing is, if you just have cold, hot, and warm, eventually you have to turn this categorical data into some numerical values. Okay, so you have to give it 001, 010, and 101, 100, sorry. So this means when you have 3 different types of categories in that variable, it means you're creating 3 different features. So instead of creating 3 different features, if you are going to merge one of the variable which does not have a high variance, then what will happen is that you are going to minimize your number of features. And then we have another approach which is known as regression analysis. I'm not going into all the mathematics of this. So the idea is you take one of the variables. Okay, so one of the variables could be, let's call it family. And this variable is the variable which is contributing the most to your predictive model. Okay, so I can keep this particular model. Then what is the next variable? Quantity. Quantity is then further improving my prediction by 3%, then price by 1%. But once I have these 3 variables, then I no longer need historical customers and the end of life of the time of my product. Okay, so there is an approach using the regression analysis. How much is a particular variable contributing? Okay, so when we talk about the feature extraction, we are taking the old school approach. So let's look at the sequence of picture at the top. So everything digital which you see they are moving pictures. Okay, so I have got this first picture here and the second picture. Between these 2 pictures, the right hand, the right leg, left leg, and the face and the body, it remains the same. Only the left hand is changing. So do I need to provide the information about the full body in my second picture? The answer is no, okay, because this is how image compression and video compression works. The only information I then need to provide is the information about the left hand. And then I can then save the information. So a lot of the techniques which you see in data science, these are old school techniques, so they take their foundation from video compression and from electrical engineering and so on. So these have been around for many decades. Okay, have a look at this image compression technique. So you can see, just rank 4, 10, 20. Just think it as some sort of amount of data. Okay, all of you would be familiar with the concept of JPEG and PNG images. If you try to save an image in the JPEG format, the image looks quite good, but it does not take as much memory as PNG format takes. Why? Because PNG does not apply any compression technique, but JPEG has some compression, right? Look at the third image here. It's, the third image and the image at the last, they look quite close to each other. When we look at the image with rank 50 and the image with rank 128, it's almost similar, very similar. You really need to magnify and see any difference. So why do we want to add some extra information or too much information just for a minor improvement? So what we can do here, we can obtain the most amount of the information from select few variables. And the main idea of showing this image was just to give you a graphical illustration that all the variables are not required. Only certain variables are required. And there are techniques in machine learning to select those variables. And I will just briefly talk about those techniques as well. Okay, so before I talk about those techniques, let's talk about the concept of entropy. Okay, so I want to give you some information. Okay, my first bullet point says so. It is going to snow in Montreal during December of this. Do you want to bet with me on this? Okay, and I think most of you will agree with me. Definitely in Montreal is going to snow during December of this year. It rains. It has snowfall takes place in December every year since like the last so many centuries. Okay. How about if I tell you Bitcoin value will increase by 40% in the next 6 months? Okay, this is the kind of information you need. This is a new information because sometimes Bitcoin value increases, sometimes it decreases. So there is a lot of surprise in this. When you talk about the gambling industry, you make bets on events where there is a large uncertainty. There's an element of surprise, two teams playing with each other. If one team is very strong, everyone knows which team is going to win. But if you have two very good teams, then it introduces uncertainty about which team is winning, and then people start betting. Okay, so this idea is analogous to volatility in finance industry. So the more volatile an investment is, the riskier it is, but it comes with higher return. Okay, so now we have understood the idea of entropy. The idea of entropy is the element of surprise. How much new information can it give to you? So now that you have understood this concept, so let's say I have got a very simple 3D data, okay, a data set with 3 dimensions. Okay, so now I can ask you this question. If from these 3 different variables, okay, PC1, PC2, PC3, which of the 2 variables are you going to keep? Anyone, like, just to keep it interactive?
PC1 and PC2.
Okay, great. Yeah. Why are we keeping PC1 and PC2? Because in PC1 and PC2, we have more variance.
Yes.
The information is changing. There is more surprise. There is more entropy in this. PC3, yeah, is giving you some information, yeah, but you can ignore it without losing a lot of information, okay? And if I ask you which one you want to keep, the answer will be PC1 because there's a more variance in that information or more surprise. Okay, guys. And one thing which, based on my own experience, if you go to interview, people really do not care too much about the mathematical details, just be able to describe them the situation or the concept in layman's terminology. Okay, so just say more surprise, more variance means this is the information I want to keep instead of going into the more mathematical details. Okay, and then there's
I'm sorry, I'm stopping you here, but I think 2 minutes are left. So
sure, no problem.
I think we can go over interview and job search part if that's okay.
No worries. Yeah, I mean, I was always about to be reaching the end of my feature selection.
Yeah, but
I'll skip this. Yeah, so this was my question and answer. So I hope because we have 2 audience members and it has been an interactive session, so I will jump over this part and I will just talk about.
Yeah, because only 2 minutes are left, so that's why I thought.
No, it's okay. It's okay. So yeah, guys, about my own experience, I think if you're coming like more from an immigrant background, like I'm coming from Pakistan, and I believe it's a very important thing just to understand the different entry barriers you have, like talking about my home country and in Canada. Like I had my own PhD. I was working as a professor back in Pakistan. But does it mean like Yeah, I was in Pakistan, Karachi. But the thing is,
I'm from Pakistan as well. That's my mom.
okay, great. Yeah. So the whole idea is, you need to understand. Okay, I can see that you have less than 1 minute is timed on Zoom. Okay.
Yeah.
Yeah. Okay.
I guess. Yes. I think we should just. I guess.
Okay. So if you have any other questions, guys, please do feel free to email me. Yep. I will stop my presentation here.
It was nice talking to you and learning from you. Definitely, you have a lot to add, but we were
Sure.
short on time.
No, it's okay. No worries. Yeah.
Okay.
Thank you very much for hosting me, guys, and I look forward to participating in future George Brown College events.
Thank you to you as well.
Okay. Okay. Thank you very much, and goodbye.